Hi! So today we're going to be reviewing Unit 3, and this is going to be all about periodic trends and what kind of patterns there are on the table. So we're going to be exploring 5 different topics: element groups, atomic radius, Coulombic attraction, ionization energy, and electronegativity. So let's go ahead and start out with some element groups. There are 6 main ones that you should really be focused in on. The first one we're going to talk about is the alkali metals. They only have one valence electron and they're highly reactive. And if you look over here at this periodic table, they're going to be in this group 1. Alright, so it's all the way lithium to francium. Hydrogen is not an alkali metal. Make sure you remember that. The second group that we have is the alkaline earth metals. They have 2 valence electrons and they're still reactive, but they're not as reactive as the alkali metals. So they're going to be over here in group 2, all the way from beryllium to radium. The next group we're going to talk about is the transition metals. And this is probably what you're going to recognize as like your regular everyday metals. They're going to vary in electrons and reactivity, and they're going to be what takes up most of the periodic table. So we have from all the way from here from group 3, and then we even have bismuth over here in group 17. But you're going to notice, you see how all of these are red, but then you have these 2 over here that are like this little green color, and that's because they transition into the lanthanides and actinides. So they're kind of like metals. They're all synthesized by humans, and they're mostly radioactive, but they're not completely radioactive. So make sure, like, if there's a test question that says, what are some properties of the lanthanides and actinides, and it says reactive, it's probably not the best choice to pick that one because not all of them are reactive. And they're going to be down here in the F block, just these 2 rows right here for you. The next thing we're going to talk about is the halogens. They have 7 valence electrons, so they're going to be highly reactive because they really want to get that full octet. And they're going to be right over here in group 7, and they're these orange elements from fluorine to actinide. The last group that I'm going to cover is the noble gases. And because they have 8 valence electrons, they're highly unreactive, and they don't really want to do anything because they're happy, so they don't really want to bond with anyone. So they just kind of sit there. But they do give off very pretty colors when you like to throw photons at them. The next thing we're going to talk about is Coulombic attraction, and that's the force of attraction between positive and negative charges. Now, there are a lot of different factors that play into this, but the most important one is distance. So distance is always going to be a greater factor than the number of protons. So if you look here at this periodic table, you'll see that Coulombic attraction increases as you go up a group, but it remains the same as you go across a period. So you're probably sitting here wondering, well, then if Coulombic attraction remains the same across a period, why does it decrease as you go down a group? And that's because of a little thing that we call electron shielding. Basically, as you move down a period, you're going to be adding more energy levels. And with those energy levels, you're adding on more electrons, and those are going to block out that positive force from the protons. The next thing we're going to talk about is atomic radius. And that's pretty simple. It's just the distance from the nucleus to the outermost electron. So you look here, we have lithium, sodium, beryllium, and magnesium. And what do you notice? If you look at this periodic table, lithium and beryllium are in the same period. And if you look back at these Bohr models I've drawn, they each have 2 energy levels. Now let's take a look at lithium and sodium. What do you notice about them? They're in the same group, but they're in different periods. So let's look back at these Bohr models, okay? Lithium has 2 energy levels, but sodium has 3. So what can you conclude? As you move across a period, the atomic radius is going to stay the same. But as you move down a group, the atomic radius is going to increase. The next thing we're going to talk about is ionization energy. Ionization energy is the amount of energy needed to remove an electron from an atom. So that's basically how attracted an electron is to its own nucleus. And the influences on that are going to be the number of protons you have in that nucleus and the distance from the nucleus. So let's take a look at this periodic table. And guess what? It's just like Coulombic attraction. It decreases as you go down a group because of that whole distance factor. But actually, it's going to increase as you go across a period because even though you have the same amount of energy levels, you have an increasing number of protons. So your electrons are going to want to stay there. But you can't really see it very well on this periodic table, but all of these noble gases are crossed out. And that's because they don't want to give up their electrons because they're happy where they are, because you know what? They have 8 valence electrons, so they're content and they're not going to want to leave that atom. So the last topic I'm going to cover in this video is electronegativity, and that's the ability of an atom's nucleus to attract additional electrons from other atoms. So it's kind of like ionization energy, but instead of wanting to pull your own atoms, your own electrons closer, it's going to want to pull other electrons into its orbit. And the factors from that are going to be distance from nucleus and electron shielding. So let's go ahead and look at the periodic table again. And you'll find that as you go down a group, it's going to decrease, and as you go across a period, it's going to increase. And that's going to make helium the most electronegative element. Alright, so that is it for my project today. Hopefully you learned a lot, and hopefully it helps you in the future. Bye!